Hi, my name is Laha and I am a physics graduate student at Ohio State University. In this video, I am going to talk about my recent work done in collaboration with Kenny Chun-Yu, Vasudev Dasgupta and Shunsaku Horiuchi, titled Galactic Center Radio Constraints on Gamma-ray lines from Dark Matter Annihilation. As is well known, dark matter has been discovered gravitationally at all scales of the universe. However, we still do not know the particle content of dark matter. One of the ways to know about the particle content of dark matter is called indirect detection, in which we search for standard model final states coming from dark matter annihilation. Recently, there has been a lot of excitement about the presence of a 130 GeV gamma-ray line at the galactic center found in the Fermi-lab data by various groups. If one assumes that this gamma-ray line arises from dark matter annihilation, then there are only three two-body standard model final states: dark matter annihilating to gamma-gamma, dark matter annihilating to a gamma and a Z boson, dark matter annihilating to a gamma and a Higgs boson. In this work, we assumed that the Higgs boson has a mass of 125 GeV. We asked the question in this work: assuming this gamma-ray line arises from dark matter annihilating to Z gamma or to Higgs gamma, is there a way to confirm or refute the presence of this line at the galactic center independent of any particle physics dark matter model? We find synchrotron constraints from electrons and positrons coming from the decay of the Z and the Higgs are very strong. In particular, we find that present radio constraints around the galactic center is in slight tension with the presence of this 130 GeV gamma-ray line for a contracted NFW dark matter profile. We also find that the presently running new generation low frequency radio telescope LOFAR will be easily able to confirm or refute the presence of this line at the galactic center. In the next slide, we show the dark matter profiles used in our work. We use the contracted NFW profile, the NFW profile and the INASTO profile in our work. In the next slide, we show the magnetic field in one of the regions of interest that we used in our work, which has an angular radius of 4 arc seconds around the galactic center. At such a small region around the galactic center, the magnetic field is highly amplified due to accretion of matter by the supermassive black hole at the galactic center. We show the two extreme forms of the magnetic field that can be present at the galactic center in this region. In this slide, we show our calculated synchrotron flux densities for 408 MHz in a region 4 arc seconds around the galactic center, for the dark matter going to Z gamma channel and for the dark matter going to Higgs gamma channel. As one can see from this figure, the NFW contracted profile gives the largest synchrotron flux density in millijansky, and the synchrotron flux density for the other dark matter profiles varies by orders of magnitude in this region, as is expected. Using the upper limit of the synchrotron flux density at this region, we try to find the constraints in the dark matter annihilation cross-section sigma v versus the dark matter mass plane. In this shaded region, we show the dark matter annihilation cross-section that is preferred if this 130 GeV line arises from dark matter annihilation. As can be seen with the current upper limit, the line is in slight tension if it arises from an NFW contracted dark matter profile. The constraints for the other profiles, the NFW profile and the INASTO profile, are about an order of magnitude weaker. Encouraged by this result, we try to see the constraints that can be obtained from LOFAR at 200 MHz. As one can see, due to superior capabilities of LOFAR can confirm or refute the presence of this line by observing the galactic center for about 6 hours. In particular, for both the NFW contracted profiles and the NFW profile, LOFAR can easily confirm or refute the presence of the line. For the INASTO profile, LOFAR might take a little longer time of observation at the galactic center. I hope I have been able to convey the main message in our paper. Using present-day radio data, the presence of the gamma-ray line is in slight tension if it arises from an NFW contracted dark matter profile. However, LOFAR can easily confirm or refute the presence of this line using observations of the galactic center for about a few hours. Although our work depends on the modeling of the galactic center, we find that the dependence is very modest. We also want to emphasize that our work is independent of any particle physics dark matter model, since we have taken the electrons and positrons only from the Z decay and the Higgs decay. Although our work has been motivated by the presence of this 130 GeV gamma-ray line, our limits are applicable for any gamma-ray line ever found at the galactic center. We hope you will enjoy reading our paper, which has been posted in the hep-ph server and in the astro-ph server. Thank you.